Okay, our last lesson for the chapter is lesson 5.5, and we are actually only going to do the first part, which is multiple angle identities. Double angle, power reducing, and half angle identities. So the first one we have is the sine of 2 theta. Sine of 2 theta equals 2 times the sine of theta cosine of theta. There's an example of the proof down here in case you're interested. You can look. I'm happy to give you any of these if you want to come see me. Tangent of 2 theta is similar to our tangent sum that we talked about yesterday. So that's going to be 2 tangent theta over 1 minus tangent squared theta. Now, notice that we have 3 lines for the cosine, and that's because there are multiple versions of it. The one that I remember, cosine squared theta minus sine squared theta. And then if you apply the identities that we have, then you could also put in there um, 2 cosine squared theta minus 1. Or if you did it the other way, it would be 1 minus 2 sine squared theta. There are different reasons that each one is appropriate, and we'll try to go through each of those. Okay, so let's work with these formulas and go forth. Cosine of theta equals 3/5 on the interval from 0 to 2 pi. Find the sine of 2 theta. So we're going to find the sine of 2 theta. We're going to find the cosine of 2 theta. And we're going to find the tangent of 2 theta. So first off, we'll find the sine of 2 theta. And that is equal to, let me work down because then I'll do each example. Uh, let's see, the sine of 2 theta, that's equal to 2 times the sine of theta cosine of theta. Okay, so we probably need to go back because what we're going to do is we're going to fill in for each of these. 2 times what's the sine, what's the cosine. So I need to come over here and actually draw this. So let's draw our triangle. And we have theta over here. If the cosine is 3 over 5, that's adjacent over hypotenuse. And hopefully you recognize the Pythagorean triple, so that's a 3, 4, 5 triangle. So now to go fill it in, what is the sine of theta? Opposite over hypotenuse. So that is 4/5. Cosine we already know is 3/5. So we multiply that out and we get 24 over 25. So that is the sine of 2 theta. Now let's look at the cosine of 2 theta. You have 3 formulas. I would go with what they gave me. So if they give me the cosine, I'm going to use, I said I was going to work down, didn't I? Cosine of 2 theta. I'm going to use the formula that has just the cosine in it because then in case I make a mistake calculating my sine. So the cosine of 2 theta, the one with only a cosine is 2 cosine squared theta minus 1. What is my cosine of theta? They gave it to me as 3/5. So that's 2 times 9 is 18 over 25 minus 25 over 25, which is negative 7 over 25. Okay, so my cosine is negative, my sine is positive. Now on this last one, we have a tangent double angle. Sometimes it's not the best to use. Keep in mind that tangent of any angle is equal to the sine of that angle over the cosine of that angle. So if you've already calculated it, sine was 24 over 25, and the cosine was negative 7 over 25, making my tangent equal to negative 24 over 7. So sometimes, I mean, don't make it hard, but if you have any difficulty, then that's something else you can use, or use your double angle formula. Okay, so let's talk about solving equations and using our double angle formula. Now, when we solve equations, Okay, you got to keep in mind that these two have to be the same or you're not going to be able to solve it. So that being said, we need to make a substitution here with the cosine of 2 theta. Um, I have sine squared over here, so I'm going to use the substitution of 1 minus 2 sine squared alpha equal to negative sine squared alpha. Okay, I have one trig function, so to simplify that, I'm just going to put my trig functions on one side and my variables on the other. So 1 equals, if I add that, I'm going to get 1 equals the sine squared of alpha. Take the square root of both sides, write that, and that gives us plus or minus 1 is equal to the sine of alpha. They asked us for those answers over the interval of 0 to 2 pi. So where is the sign plus or minus 1 between 0 and 2 pi? And quickly, from a unit circle, you can tell that's pi over 2 and 3 pi over 2. So that's our answer. Okay, so again, look at what we've got. We have the tangent of 2 beta and beta, so I'm going to make a substitution with my tangent of 2 beta. And that equals 2 times the tangent of beta over 1 minus tangent squared of beta. And that equals 2 tangent of beta. Now, you might consider putting that over 1 and cross multiplying, but before you do that, if you notice these two are the same, if those are the same, these two have to be the same. So I'm going to go ahead and say that 1 minus the tangent squared of beta is equal to 1. I'm going to subtract 1 and have negative tangent squared beta equals 0, which of course means the tangent squared of beta equals 0. Take the square root of both sides, and the tangent of beta equals plus or minus 0, which is just 0. So beta equals, where's tangent 0? At 0 and pi. Okay, some more identities. Power reducing identities. Okay, again, there's a little proof down here, but I'm going to write them in quickly so we can move on. The sine squared of theta is 1 minus the cosine of 2 theta over 2. The cosine squared of theta is 1 plus the cosine of 2 theta over 2. And the tangent is 1 minus the cosine of 2 theta over 1 plus the cosine of 2 theta. These actually are used a lot in calculus for those of y'all who are going on, so we need to make sure we know how to use them. Now, our examples, rewrite each expression in terms with no power greater than 1. So we're trying to reduce the power of our function. So I have cosine to the fourth of x. Now, hopefully y'all can see from that that we have, that is the cosine squared of x squared. So from there, I'm going to go to using my power reducing formula that we just talked about. Cosine is 1 plus cosine of 2 theta over 2. So I just reduced the inside. This thing is still squared. Okay? So to go forth from there, we need to multiply that binomial. So that's 1, multiply them together, times 2 gives me 2 times the cosine of 2 theta plus cosine squared of 2 theta. And of course, we square our 2 and get 4. So I still have one more power in there that I got to get rid of. So I'm going to write on top, I'm going to have 1 plus 2 cosine of 2 theta plus Okay, my squared, when I have the cosine squared, that is 1 plus the cosine of, I kind of squinched myself in there. Let's make that a little bigger. It's 1 plus the cosine of 2 theta, and my theta this time is 2 theta over 2, and we write that all over 4. Now we have to simplify that. And they're gonna go. So my next step here, I'm going to do something that I've talked to y'all about in class, which I prefer to simplify a complex fraction. This has a denominator of 2. There is no other fraction in my complex fraction. So I'm going to multiply this fraction top and bottom by 2. So when I multiply 2 times 1, I get 2. 2 times this expression gives me 4 times the cosine of 2 theta. And 2 times this expression wipes out that. So then I have 1 plus the cosine of 4 theta over 2 times 4, which is 8. So the only thing left that we have to do is to simplify any terms. And sometimes they write this out front, so I just want you to be familiar with it. I don't really care which way you do it. 2 plus 1 is 3 plus 4 times the cosine of 2 theta plus the cosine of 4 theta. And we're done. Okay, look at our next one. We have sine cubed times sine cubed of theta. So hopefully you can see that that of course would be sine squared theta times the sine of theta. And if we use our power reducing formula, then the sine squared is going to be 1 minus the cosine of 2 theta all over 2 times the sine of theta. Okay, so to simplify that, you can leave it again. I'll write it the other way. I'm going to actually go ahead and FOIL that out. So that's going to give me, not FOIL, but distribute. Um, if I pull my 1/2 to the front, sine times 1 is the sine of theta, and sine times cosine is going to be the sine of theta cosine of 2 theta. And we have effectively reduced the power of our expression. Okay, now let's go solve an equation. Sometimes that's helpful. In this particular one, I looked at this problem and I see cosine to the fourth sine fourth. I'm going to think that that is the difference of two perfect squares. So I'm going to write cosine squared alpha plus sine squared alpha times cosine squared alpha minus sine squared alpha equal to 1/2. Okay, what is cosine squared plus sine squared? It equals 1, so I don't need to worry about that anymore. So I have cosine squared minus sine squared. Um, a reducing formula, cosine squared minus sine squared, that is the expression of my cosine double angle. So that gives me cosine of 2 theta equal to 1/2. If the cosine of 2 theta equals 1/2, then 2 theta must equal, where's the cosine 1/2? At pi over 3 and 5 pi over 3. Okay, they didn't specify only over the interval 0 to 2 pi, so we need to think about the coterminal angles. So one of the things that you need to remember or notice, okay, there's several ways you can go about this, but if this angle is not theta, then you need to remember that that affects my period. The normal period is 2 pi, but now it is 2 pi over 2, which is pi. So when I come down to this next step that I'm fixing to do, I'm going to have to add back. I didn't finish solving that for theta. Theta equals pi over 6 and 5 pi over 6. But I have to add back what makes them coterminal, and you add back the period, okay? And my period is pi in this case. So the final answer that I'm going to have on this is going to be theta equals pi over 6 plus pi n, 5 pi over 6 plus pi n, in an element of our integers. Okay? Now remember, y'all, when you're watching this, if you have any questions, write them down, email me, or come see me and get those cleared up. Okay, in the interest of time right now, I don't want to make the video too long, and you don't have anything like it in your assignment this time. So I'm going to eliminate that example. Try to get through here. We have our half angle identities. These are ones that I was never made to memorize. Um, so we're just going to go forward with it. We have the sine of theta over 2, cosine of theta over 2, and the tangent of theta over 2. Now, notice that we have three values over here. Okay, the one that I like to use most is going to be this one right here because uh, it doesn't want me to go back and forth because my denominator is just the sine of theta instead of having 1 plus the cosine or having some kind of radical. You can use whichever one you want, but let's go forth. So the sine of 75, okay? You can divide it by 2, but also if you, because we've talked about that earlier, but if we multiply it by 2, it actually gives us an angle that we know on our unit circle. So I'm going to rewrite that as the sine of 150 over 2. Okay, now 150 over 2, my sine formula is plus or minus the square root. Okay, what angle am I working on, y'all? 75 degrees. What quadrant is that? That's in quadrant 1. So is my sign going to be positive or negative? Hopefully you said positive. So that's what determines which one of those you choose. Okay? So my formula is 1 minus the cosine of 150 over 2. Now we simplify that. Okay? And as I said, I like to do that, well, we're going to multiply by 2 over 2. And that's going to give us, and that's underneath my radical. So you can think of it as, oh, I didn't put, well, we can let's go do this. Um, Before we rationalize it, let's go put in what the cosine of 150 is. So let's go 1 minus cosine of 150 is negative square root of 3 over 2, all over 2. All right, now I'm going to go multiply by 2 over 2, and that's going to give me 1 times 2 is 2, plus that 2 cancels, leaving me with the square root of 3 over 4. 2 times 2 is 4. We don't want to leave that radical in the bottom, so we simplify that to our final answer, which is square root of 2 plus the square root of 3 all over 2. Okay, that was with degrees. Let's do one with radians, and then we're going to solve one more problem and be done. Tangent of 7 pi over 12. Okay, again, multiply it by 2. 7 pi over 12 multiplied by 2 is 7 pi over 6. So that tells me that this is half of that angle. So I'm going to write the tangent of 7 pi over 12 over 2. So this is my theta over 2. So my tangent formula, if you look back up here real quick, I'm going to use that one that says 1 minus the cosine. So I'm going to write 1 minus the cosine of 7 pi over, okay, where are my students to tell me that was supposed to be a 6, y'all? Right there. Okay, that's what we said. Because 7 pi over 6, I can't write that over. You got the idea. So it's 1 minus the cosine of 7 pi over 6 over the sine of 7 pi over 6. Again, using those values that we have from our unit circle. What's the cosine of 7 pi over 6? It is negative square root of 3 over 2. What's the sine of 7 pi over 6? Negative 1/2. So I'm going to, again, there's my complex fractions that I'm going to multiply top and bottom by the least common denominator. 2 times 1 is 2. Negative and a negative is a positive. If I have a fraction, it cancels. So I get 2 plus the square root of 3. That one cancels as well over negative 1. And of course, I didn't write negative 1. I said negative 1, but I didn't write it. So bring that up, and that gives me a final answer of 2, negative 2 minus the square root of 3. Okay, one more problem. Solving. If you feel comfortable solving, turn off, go get to work. All right, but I'm going to do one where we're going to use our half angle identity to go through the problem. So I have a half angle here, and I need to get rid of that half angle. So I'm going to have 2 times the half angle is plus or minus. I don't know anything about it, so I have to keep that plus or minus in there. 1 minus the cosine, and we're not dealing with theta plus or minus 1 minus the cosine of x over 2. Okay, that's my sine half angle. Now I have to square it. Plus the cosine of x plus, I mean, equals 1 plus the sine of x. So what happens when I square that out? Okay, that 2 is not squared. Okay, my plus or minus goes away, and my radical goes away. So I'm left with 1 minus the cosine of x over 2 plus my cosine of x equals 1 plus the sine of x. Okay, so simplifying that, okay, 2 and 2 goes away. I got a minus cosine and a plus cosine. So it looks like I have 1 equals 1 plus the sine of x. So I'm going to subtract my 1. 0 equals the sine of x. So what does that mean x equals? Where is the sine 0? This time I am on the interval of 0 to 2 pi. And the sine is 0 at 0 and pi. That sums up multiple angle identities. Please come see me if you have questions, and we'll work together in class.